All right, unit review, find the inverse, graph the inverse and the original function. A couple changes we need to make here. I know I noted it on the board. Just look at these two text boxes that are on my paper and go ahead and make the changes. You will not have to identify the x and y intercepts. They're not pretty points on this one. And I switched up the horizontal and vertical asymptotes there. So let's start. I'm going to get the original function on the graph to start. So my original function is ln of x minus 3 plus 2. So that means I'm moving my function right 3 and up 2 units. So right 3 means my asymptote is going to move from the y-axis to the line x equals 3. Up 2 means that I'm going to, this dotted line here that I'll get rid of in a second, that's going to be my new x-axis. I'm moving up there. So my first point here is going to be at 4, 2. That is that first point. That would have been where our graph crossed the x-axis if we would have moved it up. All right. And then from this little hash mark here in the center, we go over 2, between 2 and 3, up 1, and over 7, between 7 and 8, and we would go up 2. That one doesn't really fit on our graph, but I'm going to put it there to help me draw it. For this function, the domain is 3 to infinity, not including 3. Our asymptote to positive infinity. Our range is all reals. And our end behavior as x approaches infinity. As x is getting bigger, my function is going out faster than it's going up, but it's still going up forever. So y approaches infinity. It is an increasing function. All right, we need to find the inverse now so that we can graph the inverse. So that's my next project on this problem. To find the inverse, I'm going to switch out of x to y. Switch x and y. And solve for y. So be careful when you're solving for y here. I like to show my steps because it's really easy to switch up a sign if you're not showing your steps. Subtract the 2 first. So my base here is e since I'm doing a natural log. And if this is the piece that you're struggling with, I have students that struggle with this piece every year, label, base, exponent, other side of the equal sign. Label it now. Go back and label problems that you've done before until it just becomes second nature. Because this is the problem, this is the piece of the problem that is so important. This is the kind of thing you have to be able to do when you get to calculus, kind of without even thinking about it. There's no other way to get rid of that logarithm. Logarithms and exponentials undo each other. You have to use the exponential to undo it. All right, last thing, add 3, both sides. And the 3 is it's down on the same level as the e. We're going to label it as the inverse. So I have e to the x minus 2 plus 3. So let's talk about our transformations of this one. X minus 2, so that means I'm going to be moving right 2. so I'm going to be moving up 3. So instead of having a horizontal asymptote at 0, we're going to move up 3. Our horizontal asymptote is going to be at y equals 3. Again, we have this relationship here that you can use to double check. Oh, x equals 3, y equals 3. That's how inverses work. All right, let's graph our transformations here. So e to the x usually goes to the y-axis 1 unit up from our asymptote, but we're moving right 2. So I'm going to dot that in, just kind of like I dotted in my other, when we moved the logarithm up. I'm going to dot in where we moved this over. So I'm going to ignore the y-axis and use my orange dotted line here. I'm going to go through my vertical orange dotted line at 2, 4. Okay, we had this point at 4, 2 over here, so that's beautiful, looking good. Our exponential, I'm going to go over 1 more and up between 2 and 3. Over 1 more, up between 7 and 8. My ordered pairs should be flips of each other. I have the 0.42 on my logarithm. I have the 0.24 on my exponential. My graph should be symmetric over the line y equals x, which goes right through here. And that's looking awfully pretty. All right, domain as my exponential function is all reals. I'm using every x value from left to right. Range of my exponential, well, I have this asymptote at 3, and then we're going up from there. So 3, 2, and 50. The last thing we need to do is talk about end behavior for this exponential. We can talk about this in both directions. As x approaches negative infinity, our exponential is going, our y is going to approach 3. As our x's get negative, we're flattening out to 3. We're never going to get there, but we're going to get dangerously close. As x approaches infinity, y approaches infinity. As my x's get really big, our y's are getting really big. Really, really big. Because this is an exponential. All right, that's number 1 on your review.